Oh, dude!
What's going on?
I haven't seen you in a while.
Right?
How you been, man? Yeah, how you doing?
What 3 things do we need to make a fire? If I remove any of those components, my fire goes out. Where this can get dangerous in the Oxy-Fuel world is our atmosphere is roughly 20% oxygen. I know it's not exact, but I like nice even round numbers, so I'll keep it simple. So things that will burn in our atmosphere, paper, cardboard, whatever it might be, in a pure oxygen environment are going to burn 5 times faster. Things that won't burn in our environment, brass, steel, wool, things like that. I can put flame to it, it'll get hot, it might deform, but it's not going to just burn unless I put it in a pure oxygen environment. And that's where bad things can happen in the shop, because now we get what we call a flashback, or we get a sustained backfire. Now the flame is burning inside the torch starts burning, people panic, they run for the hills, I'm feeding straight oxygen to it, and now my hose, my torch, whatever it might be, becomes the fuel. So one of the things you'll see that we do and what we recommend is always oxygen first, oxygen first, oxygen first. So when I do setup, when I do shutdown, I'm always going to oxygen first. We want to shut off that oxygen, take that out of the triangle, so now my brass component that's laying on the floor on fire will no longer burn. All right, so when we start talking about regulators, so we're going to hook up our regulator to our cylinder and we're going to set it to something. How do we know what to set it to? What size tip are you using? What fuel gas are you using? For how much pressure we want to go to the tip chart so we know what we're using. I think you guys are pretty familiar with how acetylene cylinders are made. It's the only pressurized gas cylinder that's not hollow, and there's acetone in the bottom. First bold statement, never exceed 1/7 the volume of an acetylene cylinder. All right, so what the heck does that mean? Every cylinder is going to have a volume. In this case, I get 46 cubic feet per hour. If I pull more than that out of my cylinder, I can start pulling acetone into the system. Well, how do I know how much I'm going to pull out of it? On the left, up here, you'll see metal thickness, tip size. I've got some pressure settings. I've got acetylene consumption. That column never gets looked at. It's not as common in cutting tips, but in heating tips especially, this is where we can really get into a lot of issues. I want to know what my consumption is for whatever attachment I have on my handle. Number 8, very common. You guys probably have it sitting on the shelf right now. If somebody comes in and says, I need a rosebud, yep, they're right over there. What size do you need? The biggest one you got. That's usually where it goes. All right? You're probably not thinking, man, I wonder if that guy's got the right size acetylene cylinder for that number 8 rosebud. He goes, he picks it off the counter, he brings it to you and says, here, I want to buy this. You say, thank you very much, I'll take your money. Here's your rosebud, sir. Have a good day. Thank you for choosing purity, right? That's how it goes. I have a range of pressures that I can use. The other thing that we've always been taught is never use acetylene over 15 psi. But if I look at my consumption, I've got a big range from 10 to 15 and how much that rosebud needs to run properly. So typically what happens is it'll run good for 5, 10, 15 minutes, and then all of a sudden it starts popping. And then it gets worse. It pops, pops, pops. And a lot of the more veteran people, I'll always use that term, they're like, oh, that's what rosebuds do. That's just what happens when you run a heating attachment. They get so hot it just pops. Any Oxy-Fuel system, if it's set up properly, should not pop. It's going to happen. You might bump it, or you might have forgotten to make an adjustment or whatever. So it does happen occasionally, but it's not supposed to. I'm allowed 46. I'm probably, if I'm at 14, I'm probably around 70. So I would actually need 2 of those big 300 cubic feet cylinders to properly feed that rosebud. And there's nothing I can do to change that. I can't just throttle back on the valves or anything like that. If I'm going to run it at a given pressure, I need a certain amount of volume. Yeah, so that's another way to reverse engineer this. If a guy comes up and says, okay, I want this really nice contender kit. Man, that thing's awesome and Purity's got a smoking deal on it. All right? It's got everything I need in it. Now they're going to come to you and go, what do I need? I need gas. I look at my attachment, number 8, the minimum, 30. Multiply that by 7, I need a cylinder that has at least 210 cubic feet in it to properly feed a number 8 rosebud.
On the low side.
On the low side. My general approach is if you're going to be primarily cutting and occasionally heating, acetylene might be better. It's probably going to be a little bit faster on the cutting side. If they're mostly heating and they're just going to do some occasional cutting, go with propane or propylene. It's a lot safer. You don't have to worry about that 1/7 roll. I can put a massive rosebud on there and I don't have those safety concerns, right? The other thing real quick is there are 2 different types of hoses. All of our outfits come with T grade, so they're rated for all fuels. I don't know why they just don't get rid of R grade if T works for everything. You definitely don't want to use R grade with your alternate fuels, propane, propylene. I think it's propylene. If the system is left pressurized within like 45 minutes to an hour, it can actually start swelling the hose to the point where it can burst, and now you're filling your room with a fuel gas and plenty of oxygen in the air to make a boom. The guy that started Victor lost an eye in an industrial accident. I think it was a regulator that blew up. And he's like, there's gotta be a safer way to do this. Just some of the safety features that we've built into the Edge. This is the safest regulator on the market. All the Victor stuff that is rated like light duty, medium duty, heavy duty, it's not a durability, it's kind of mismarketed. It's flow capacity. So we released the Edge and then we improved it a little bit. So there was an Edge, and then the Edge 2.0 is just the next version of the Edge. But both, the medium and heavy duty, are both Edge 2.0. We changed the gauges. We made the delivery side bigger than the source side of the gauge because that's what people are more concerned about. The original Edge, they were both the same. We extended the stem a little bit to make it easier to get a wrench on it to tighten it. The first one was a little bit tighter. The safety features are the same, but we just made some few improvements. So we rounded everything off so there weren't sharp edges, just little stuff.